Okay, let's have a go at this then. Believe the rust on the metal plate is follows this relationship here. S equals AE to the BT, where the S is the surface area, T is the time. So we've got that here. Here's the data that's been obtained. So let's have a look at this then. This is in the air. Log base C would be best, wouldn't it? So ln log E of the S is equal to log E of A times you add, so it would be plus log E of E to the BT, which is just BT log E. BT log E plus log A. And that's ln S. So in other words, log S is equal to log E is 1, so that's B times T plus ln A. Y equals M X plus the intercept C. So here we can read off the correspondences. So the gradient B equals M. That's the gradient B when we draw the plot of log S against T. Y is log S and the x-axis is T, and C log A will be the intercept C. Okay, let's see what we get then. So we're going to have to draw T against log S. So T equals 2, 3, 4, 5, 6, 7, 8. And we need to plot log of S on a chart. So 2.34, log to base E, 2.34, 0.85, 2.75, 1.01, and 3.16, 1.15, and then 3.63, 1.29. Okay, and then the next one, which is number 6, 4.16, ln 4.16, 1.43, ln 7. The next one, 4.79 is now 1.57, and then the last one, 5.62, log of that, 5.62, 1.73. Okay, that's what we've got then as data. So let's have a look at the data then, draw the graph. 2, 3, 4, T is the x-axis, and we've got the y-axis here. Let's draw it in. Okay. Now I use graph paper, of course, but I haven't got graph paper. I've just got a digital pen. So I'll do as best and as accurately as I can draw. 6, 7, 8, 9. So this is T. 1, 2, 3, 4, 5, 6, 7, 8, 9. And log S, the highest value is 1.57, so we'll go up to 2, say. So 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8. This is log S. 0.2, 0.4, 0.8, 1.0, 1.2, 1.4, 6, 1.8, and then 2.0. Okay, good. This is the x-axis, which is T. This is the y-axis, which is log S. Now we can plot the points 2 and 0.85. As accurately as you can on your graph paper when you do this example. 3 and 1.01. 4 and 1.15. 5 and 1.29, 6 and 1.43, 7 and 1.57, 8 and 1.73. So I've done my best with these limitations I've got. So let's draw the graph then. So I'm going to try and draw a straight line now. I'll try and find my digital pen a minute. Here it is. So I'm going to come down to about here. Something like that. I'm trying to draw it as best as I can. Should have come down a bit lower, shouldn't I? So let's just try it again. So I'll try my best to come down here. Try and see where the digital marker is. It's difficult to spot sometimes. Well, I'm making several attempts here, but that's probably best. Yeah, I think I got it now, more or less. So there's the line. Okay, good. Now I'm going to draw a triangle underneath it then. The intercept I can read off here. I'm going to read that off as 0.57, and I'm going to draw a gradient now from 0 to say 5 to there, and I've got to put 5 then. I'll go up here, and that I'm going to say that's 1.3. So it's 1.3, and this is 0.57. This is 1.30. So the height here, oops, is 0.73, and the distance across is 5. So the gradient m is equal to the increase in y divided by the increase in x, 5. And if you double it, you've got 10. So it's 1.46, isn't it? Which is 0.146 on the calculator. Just check it. 0.75 divided 73 divided by 5. 0.146, yeah, that's okay. So we know our gradient, we know our intercept, so we can read off the values, can't we? So here, let's just do it up here now. The intercept was b. That's the gradient rather. B is m, isn't it? Here. So b is 0.146. And log a, natural logarithm, is equal to the intercept c, which was 0.57. So that can tell us what a is then, can't it? So shift log of natural logarithm, 0.57. To undo a log, 1.77. So I'm going to put the law over here. So what have we got then? The law, we've got a and b. So s is equal to 1.77 e to the b, 0.146 times the time. And there's the relationship between the two things.